this video we are going to see some problems related to greatest common factor and least common multiple. I have put the link of the related videos in the description section. Today's problem is find the greatest common factor of 156 and 321. Today we are going to do with the ladder method. So it has a common factor of 3. And further it is not going to have any common factor. Here we have to find the greatest common factor. So 3 is the answer. Okay. GCF for 156 and 321. Okay. Find the smallest number which is exactly divisible by number 21 and 35. So we have to find the number which is divisible by 21 and 35. Okay. So for that we have to take the LCM. 21 is divisible by 7 3 times and 5 times. 7 times 3 times 5 is 105. So 105 is the number which divides both 21 and 35 without any remainder. If we check, yes, 105 is divisible by 21 5 times and 105 is divisible by 35 7 times, okay, without any reminders. So yes, the answer is right. No, this is 3 times. Okay, 3 times, sorry. Okay, next is find the smallest number which when divided by 15 and 24 leaves a remainder of 13. Right? So in such a case, first we will find the LCM. So it is 5 and 8. So 8 times 5 times 3 is 120. Okay. So now what we have to do is this number is completely divisible by 15 and 24. But we want a number which leaves a remainder of 13. That means we have to add that remainder. So if we take 123 as a number, this is the smallest number, okay, which when divided by 15 and 24 will automatically give this. Okay, let's check 123 by 15. Okay, so this is going to be 8 times 15 and remainder 13 will be there. Okay, if we divide 123 by 24, it will go for 5 times remainder 30. Okay, it's proved. So the simplest way thing is we have to take the LCM and then we have to add the remainder, because when we find the LCM the number is going to be completely divisible, right? So when we add the 13, then the number will have a remainder when it's divided. Okay. Next, find the least number which when divided by 8, 12, 20, 36 leaves a remainder of 6, 10, 18, 34. Let's first see what is the difference between the problem above and this. Okay, in the above problem both the numbers 15 and 24 left a common remainder, that is 13. But here the numbers 8, 12 and 20 and 36 are going to divide by the same number, but they are going to get different reminders 8, 10, 18 and 34. In this case what we have to do is just find out what is the difference between this two. Okay, see, there is a commonality in the difference. It will be there like this. If it is going to be like this, then we have to follow the steps, that is take the numbers, find the LCM. So this will go by 4, and you can take another of 3 as an LCM for these two numbers. So we're just going to continue with this. And now we find the LCM to be 360. Okay, so now what we have to do is we have to subtract the common difference between the number and the remainder. Okay, we have to subtract the difference, not the remainder. We have to subtract the difference, because if we subtract the reminders, it will be different numbers will be getting, right? But we want only to find one least number which divides all these numbers, right? So we have to subtract the difference, thereby we'll be getting one number which is 358. Okay, if we just, you can try it out. That is, like, if you divide this by 8, okay, we will be getting 44 times remainder 2. Okay, sorry, remainder 6. Okay, if we divide this number by 358 by suppose 12, okay, then you'll be getting 29 times remainder 10, and so on. Okay, so it will be corresponding to the thing that is asked. 8 means it has to have a remainder 6, right? When it is divided by 8, it has the remainder 6. When it is divided by 12, it will have the remainder 10. So when it is divided by 12, it has the remainder 10, and so forth. It will be same, and so it is hence proved that 358 is the least number, which when divided by 8, 12, 20 and 36 leaves the remainder 6, 9, 10 and 34. Okay, the answer is 358. So you have to observe the question, what is given, and then we have to proceed with the methodology. Okay, so now we will see what is the largest number that divides 965 and 380. Okay, so here we have to divide the number 965 and 380 and find the number which is going to leave a remainder of 5. Okay, in this case what we have to do is we have to subtract the remainder initially. Okay, and then we have to find the GCF, because we have to find the common number which is going to be divided, right, and the largest number. So we have to find the GCF for this. Okay, 3 times and 5 times, right? So after this we are not having any common factors, so we'll stop with this. So 15 is the GCF, right? So 15 is the least number, which when divides 965 and okay, it will give you 64 remainder 5, and if it when it divides 380, it will give 25 times remainder 5. Okay, so 15 is the answer, the largest number that divides 965 and 380, leaving a remainder of 5. Okay, next question is, again there is going to be 2 remainders. Okay, as we saw in the smallest numbers, also here also these two numbers 919 and 313 is going to leave a remainder 7 and 9 respectively. So here there is no problem, because we are just going to subtract the numbers initially, right? So we are not having any problem in changing the procedures. Okay, we just subtract the numbers and we are going to proceed the finding the GCF. Okay, so it is 4 times again, we can go for another 4 times. we can go for 19. So 3 times and 1. So multiplying 4 times 19. Okay, because we have to find the largest number, that is the only the GCF. So 4 times 19, which is going to be 304. So 304 is the largest number that divides 919 and 313, and going to leave a remainder of 7 and 9 respectively. You can test it out, it will be coming correct. Okay, so this is another way example where we have to find the greatest number which when divides 41, 71, 91 leaves the same remainder. They didn't give you any number. It gives a remainder of 5, it gives a remainder of 8, nothing. Okay, but they said that they will give out a same remainder. Okay, that what we are going to do with this. Okay, this sort of problems, what we have to do is we have to subtract the values. Okay, from 91 we have to subtract 71 and 41, and also from 71 we have to subtract the 41. Okay, and find out the values. Okay, now take the ladder method and find the greatest common factor for these numbers. Okay, so the greatest common factor is 10, right? So that is the number which is going to divide 41, 71, 91, and it's going to leave the same remainder. Let's just check it out. It's of curiosity, right? Whether it is going to divide the same number. So 2 times, sorry, we have to take the number what is given, right? It is 41 divided by 10. So we have to take the number 41 divided by 10, which will be 4 times remainder 1, and 71 divided by 10, which will remain 77 times remainder 1, and 91 divided by 10, 9 times remainder 1. So all the case it is giving the remainder 1, and it is always divided by 10. Okay, so this is the way we have to apply the strategies and try to find out the answer. Hope this is the last video. Yes. Okay, so I think you enjoyed the video and understood the concept and the methodology that you have to follow according to the questions answer. Okay, thank you for watching the video. Please share and watch all the videos in this playlist so that you will have a continuity of problems.